So, next topic is principal focus of spherical mirror, that is concave and convex mirror. How to define principal focus of concave and convex mirror. Before that, in your textbook, page number 161, spherical mirror heading is there. Towards the end of that page, we need to define all these terms: pole, center of curvature, radius of curvature, principal axis, principal focus, aperture, focal length. All these things, definitions are given in your textbook. Mark it in your textbook. Okay, and write a question there. Define pole, first one pole, second one center of curvature, third one radius of curvature, fourth one principal axis, on page number 161. Then on page number 162, an activity is given there, that is, you have to hold a concave mirror in your hand and direct its reflecting surface towards the sun. Direct the light reflected by the mirror to a sheet of paper held close to the mirror. Move the sheet of the paper back and forth gradually until you find on the paper sheet a bright, sharp spot of light. Hold the mirror and the paper in the same position for a few minutes. So, if you hold the mirror and the paper in the same way for a few minutes, after some time, the paper will catch fire. The paper will catch fire and produce smoke. The reason for that, the light from the sun is converged at a point, a sharp, bright spot by the mirror. This spot of light is the image of the sun on the sheet of the paper. This point is the focus of the concave mirror. The heat produced due to the concentration of sunlight ignites the paper. The distance of this image from the position of the mirror gives the approximate value of the focal length of the mirror. That activity is given in your textbook. So, when you focus the sunlight on a paper with the help of a concave mirror, it will focus the light rays, it will converge the light rays to a single point. It will converge the light rays to a single point on that paper. At that point, you will get a bright spot of the sun. That is actually the image of the sun. So, if you hold that paper and the mirror in the same way, after some time, that paper will catch fire, because the heat will be concentrated to a single point. The heat from the sunlight will be concentrated to a single point and it will catch fire. That point is known as the principal focus of the concave mirror. Principal focus of the concave mirror, and the distance between that point and that mirror. That point and that mirror is the focal length of the concave mirror. So, I will explain how to draw the principal focus of a concave mirror and convex mirror using ray diagram. So, principal focus, normally we will represent it with capital letter F. So this one is a concave mirror. The light rays will be parallel to the principal axis. It will incident on this mirror. After that, it will be reflected back and it will meet at a point on the principal axis. That point is known as a principal focus. That point is known as a principal focus. So this one, I will draw it. So first we will draw the concave mirror. So this one is a concave mirror. So this portion will not reflect the light, only this portion will reflect the light. The shaded portion will not reflect the light, only this portion will reflect the light. Now, after drawing this concave mirror, I will draw the pole of the mirror. That is the center of the reflecting surface. Now, I will draw the center of curvature. It's represented by the capital letter C. Next one, I will draw a straight line passing through the center of curvature. Next, I will draw a straight line passing through the center of curvature. Straight line passing through the center of curvature. That is the principal axis. That is the principal axis. Now, I will draw two light rays parallel to the principal axis on both sides. On the top of the principal axis, I will draw two light rays. On the bottom also, I will draw two light rays. That is parallel to the principal axis. Two straight lines parallel to the principal axis. Okay. So this one is the incident ray. It will incident on this concave mirror. Now, here also I will draw two parallel straight lines. They are also incident on the mirror. So, when it incident on this mirror, definitely reflection will take place and it will be reflected back. So, the reflected rays will meet at a point on the principal axis. The reflected rays will meet at a point on this principal axis and this point is known as the principal focus. So, this one is a reflected ray, this one is a reflected ray, this one is a reflected ray, this one is a reflected ray. So, all the reflected rays will meet at a point on the principal axis and that point is known as the principal focus of the concave mirror. Principal focus of the concave mirror. Now, this distance between the principal focus and the pole, distance between the principal focus and the pole, that distance is known as the focal length. It is denoted by the letter, small letter F. That distance is known as the focal length of the concave mirror. Okay. So, first I have drawn a concave mirror, then I mark the pole, then I mark the center of curvature, then I draw the principal axis, then I draw light rays parallel to the principal axis. After reflection, these light rays will meet at a point on the principal axis. That point is known as the principal focus of concave mirror. Then, the distance between the pole and the principal focus, that is known as focal length. Here, all the light rays will meet at a point. All the light rays will converge to a point. on the principal axis. So, concave mirror is also known as converging mirror. Converging mirror. Concave mirror is also known as converging mirror because it converges all the light rays to a single point. It will converge all the light rays to a single point. So, concave mirror is also known as converging mirror. Now, I will draw the principal focus of convex mirror. Convex mirror, the reflecting surface is curved outwards. The reflecting surface is curved outwards. So, this portion will not reflect the light, only this portion will reflect the light. Then I will mark the pole, center of curvature, a straight line passing through the pole and the center of curvature, that is the principal axis. That is a principal axis. The straight line passing through the pole and the center of curvature. That is the principal axis. Now we will draw light rays parallel to the principal axis. Two light rays parallel to the principal axis. Parallel to the principal axis. What will happen when it incident on this mirror? It will be reflected back. It will be reflected back. So, this one is a reflected ray. 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 Now, we will backtrace it. We will backtrace the reflected ray with dotted lines. So, we will draw it like this. We will backtrace it. When you draw it using a pencil and scale, this one should be the reflected ray and this dotted line should be in the straight line. When you draw it with using a pencil and scale, this reflected line and this dotted line, we are backtracing the reflected ray, that should be in the straight line. So, this point, all the reflected rays will meet at a point and that point is known as the principal focus. That point is known as the principal focus of convex mirror. Actually, the principal focus is behind the mirror. Behind the mirror. For convex. Okay. Actually, the light rays will not meet. It appears to come from this point. Okay. In concave mirror, it appears to come from this point. The light rays will appears to come from this point. That's why it's known as diverging mirror. That's why convex mirror is also known as diverging mirror. So, because all the light rays appears to come from this point. From this point, all the light rays will appear to come. So, it's known as diverging mirror.